Hello again and welcome to another math tutorial. This video has two example problems of solving 3x3 systems of equations. I am not gonna go super slow and teach these problems. I'm just gonna show how I solve it. So if you need the extra support, I would encourage you to watch the previous video on solving 3x3 systems where I actually break it down and show you exactly how to go through the steps to solve. Otherwise, if you're just here for some extra practice, go ahead and continue with the video. I would encourage you to try and solve them on your own first, and then maybe just advance and take a look at the answers at the end, or you can watch me solve the whole problem. That's completely up to you how you'd like to do this. All right, that's a long intro. Let's get to the first problem. All right, we've got our 3x3 system. Again, if you watched my previous video on solving 3x3 systems, you know I like to organize my work by labeling the equations. So I've got equation 1, equation 2, and equation 3. When I look over this, I don't want to eliminate the x's. There's a lot of multiplication that has to go into figuring that out. I like the z's because there's a 1z right there, and that's pretty easy to manipulate. I also like the y's right here because these two are already set to cancel, right? The negative, positive 4. And I could go with these two and get this to be positive 4 very easily too. So I actually think, even though there's a 1z right there, I actually think this is going to be the easiest way to do this because I've already got the cancellation right there. So that's how I'm going to begin, okay? And I'm going to condense some of my work as well just because we've got these two equations that are already canceling. So let's just go ahead and put these two together, and I'm adding. So this is going to be, and let's go ahead and label this. This is going to be equation number 4 when I put these together. So I'm going to have 6x, the y's are going to cancel. I'm going to have minus 2z equals 36. And actually, if you want, maybe we don't know until we find the other equation, but you might consider, just because all these are even numbers, you might consider making this 3x minus z equals 18. Maybe we want that to be equation number 4 instead, just because the numbers are smaller. Let's save them both for now, and then we'll decide which one we want to play with moving forward. I'm also going to, let's see, I'm going to take those top two equations. I'm going to take equation number 1 times 2, which is going to be 6x plus 4y plus 8z equals 8. I'm going to take equation 2, which is 2x minus 4y plus z equals 5. Here the y's are going to cancel, so we've got 8x plus 9z equals 13. And that's my equation number 5. And I think because of that, I like the bottom equation better. I can't reduce this any, so it's going to be easier to manipulate that minus z than it is the minus 2z. So I'm going to use the bottom equation as equation number 4. And let's make our new system out of those two. So my new system of equations is going to be 3x minus z equals 18 and 8x plus 9z equals 13. There's my equations 4 and 5. All right, let's see, moving forward with this, what can I do? I'm going to go with the z's, and I'm going to make those be negative 9 and positive 9. So I'm going to take equation number 4 times 9, which give me 27x minus 9z equals, and then 9 times 18 is 162. And then we need equation 5, which is 8x plus 9z equals 13. So 27 and 8 is 35x. The z's are going to cancel. 162 and 13 is 175. And 175 divided by 35 is 5. Okay, now we need to find z. I'm going to take this top equation, number 4. I'm going to say 3 times 5 minus z equals 18. 3 times 5 is 15, so subtract 15. I get negative z equals 3. So z equals negative 3. All right, we've got x, we've got z, we just need y. Pick whatever y you want to work on. I'm just going to take the top equation. So 3 times the x plus 2y plus 4 times the z equals 4. So I've got 15 plus 2y minus 12 equals 4. So I've got 2y plus 3 equals 4. So I got 2y equals 1. So y equals 1/2. My solution is 5, 1/2, negative 3. All right, here is my final example problem. I'm going to start again by numbering my equations. Here's number 1, here's number 2, here's number 3. I don't have to look very hard at this to know that I want to work on the x's. I've got a couple of common values here on the top and bottom, but they're both being 2. This 1x is easy to work with. So to me, that's kind of a no-brainer. We're going to work on eliminating the x's from this system. I am going to start with the top equation and the bottom equation, and I'm just going to make the top equation negative. I'm going to multiply it by negative 1. So I have negative 2x minus 5y minus 2z equals negative 4. And the bottom equation is 2x plus 4y plus 5z equals 22. So my x's being negative and positive 2 are out. I've got negative y plus 3z equals 18. And so that's equation number, actually 4. Doesn't matter which one's 4 and 5, but that's the first one I've got. So we're going to call that 4. Okay, now let's work on, I'm either going to use the top 2 equations or the bottom 2. It really doesn't matter. You pick whichever ones you want to work with. I'm just going to go ahead and work with the bottom 2. Doesn't really matter to me. So I'm going to take the second equation, I'm going to times it by negative 2, which is going to give me negative 2x plus 6y minus 6z equals negative 28. And the bottom equation, equation 3, is 2x plus 4y plus 5z equals 22. So again, these x's are going to cancel. We've got 10y minus z equals negative 6. And that equation, oops, that is our equation number 5. All right, let's put those together and take a look at what we've got. We have negative y plus 3z equals 18. And we have 10y minus z equals negative 6. There's our equation 4 and 5. I think we could go with either eliminating the y or the z. I do think that taking care of the z is probably going to be easier because the number's smaller. So let's do that. I'm going to take equation number 4 and 5, and I'm going to take equation 5 times 3. So we're not going to change the top one. But the bottom one times 3 is going to give me 30y minus 3z equals negative 18. Here the z's, the positive and negative 3 cancel. So we get 29y equals 0, which is okay. Divide 0 by 29, we get 0. Okay, so now let's find the z. I'm going to take this top equation. Y is 0, so we don't even need to put it in. We just have 3z equals 18. So z equals 6. All right. Now we need to find x. Let's look at any of these equations from the beginning. I'm going to take the middle equation. It's got x minus 3y, but y is 0, so that whole thing just goes away. Plus 3z, and z is 6, equals 14. So we got x plus 18 equals 14. Subtract 18. X equals negative 4. Okay, we have our x, our y, and our z. Solve for. Our solution is negative 4, 0, 6. Okay, that concludes this extra practice tutorial video. I hope you found these two extra practice problems helpful. If you do need some extra help, please go ahead and leave a comment or a question down below. If you found it helpful, please give the video a thumbs up to support the channel. Thank you for taking this journey with me through this chapter 1 of Algebra 2. I hope you continue on to chapter 2, where I'll see you in the next video.